right, let's continue. So last time we talked about the parent function. Yeah, everybody, let's get moving again. Line. Parabola. Yeah. Cubic function. Square root. That side. Yeah, that side. Cube root. Yeah. Absolute value. Okay. And reciprocal, right? Yes. Okay. Good. And then last time we also talked about the domain and range. The domain is the set of inputs. You kind of project the graph on the x-axis, right? And if the point is missing, you put an open circle. If the point is included, you put a solid circle, right? And range is you project on the y-axis. Remember this problem? Yeah, so imagine the sun and then you're laying on the beach. Look at your shadow. Hi. Okay, so this is given the graph, we can find the domain and range. And how about if we're given a formula? How do we find the domain? Okay. Yeah, this is x squared minus 9. Okay. Yes. So remember two things. First thing is, okay, when you see square root of a, you need the things inside the square root to be greater or equal to 0. Right, everybody? Why is that? Okay, again, what's the graph of square roots? Like that, right? Do you see the domain is all greater or equal to 0? Right? Do you have any points less than 0? No. So the domain, everything inside the square root must be greater or equal to 0. And the second thing is when you see fraction, what do you need about the denominator? Yeah, it cannot be 0, right? Denominator cannot be 0. Do we have any restriction on the numerator? No, we just care about the denominator. Okay. So yeah, these two special functions has restricted domain. Now let's look at our problem. This is a fraction, right? So we need the denominator not equal to 0. So we set the denominator x squared minus 9 not equal to 0. Okay? And we want to solve for x. So how to solve inequality like that? Well, to solve inequality or equation, you move all the terms to the left-hand side, and then you factor, right? Do you remember how do you factor x squared minus 9? Okay.
Add 9 first.
So when you work with
That's the other one.
when you work with equation, you can move the 9 to the other side and take square roots. But this is for equation. But for inequality, you cannot do that.
Would be x plus 3.
Yeah, very good. So yeah, x plus 3. Yeah, the factor form. Right. Okay, how about let's review the formula. So if you have a squared plus b squared, this can be factored. Just leave it like that. We cannot factor. If you have a squared minus b squared, that is a plus b times a minus b. Right? Difference of squares. And how about complete square? A plus b squared is a squared plus 2ab plus b squared. Do you remember that, everybody? Mm-hmm. And if you have a minus b squared, That is a squared minus 2ab plus b squared. Okay, everybody? So here, this is how we factor x squared minus 9 is like 3 squared. So we have x plus 3 times x minus 3. Okay, everybody? Yes.
So when it's like on the outside like that 2, you gotta multiply that 2 by everything on the inside.
Which 2?
Like at the bottom, so you gotta go like a to the second power. You gotta go plus b.
Yes, and plus 2ab. Okay, why you have the 2ab?
Yeah.
Because it's a plus b times a plus b, right? When you distribute, a times a is a squared. And then a times b is ab. And then b times a is ba. And then b times b is b squared. Do you see ab and ba are the same?
Yeah, I forgot about that.
Yeah, that's why you have the 2ab. And if you have, this is minus, what happens? If this is minus, then a times a minus a times b, right? So this becomes minus. And you still have b times a and b times minus b. This becomes minus. That's why this cancels. You get a squared minus b squared. That's why you get this one. Yes?
Did you start the recording?
Oh, let's check. Okay. Okay, yes, I did. Okay, thank you. Yeah. Good. Okay.
And she told us to remind her.
Yes. Yeah, remind me every day. Yes. Okay, so we got this. The product of these two factors is not 0. Okay. And when you work with equation, it's different than you work with inequality. So if you have a times b is 0, this is the same as a equal to 0 or b equal to 0. Do we know that, everybody? But if you have a times b not equal to 0, this is the same as saying a is not equal to 0 and b is not equal to 0. Both of them cannot be 0. Because if one of them is 0, when you multiply them, you get 0. So you need both of them cannot be 0. You see the difference between here, you put or. Here, you put and. Both of them cannot be 0. So in this case, we have x plus 3 cannot be 0 and x minus 3 cannot be 0. Right, everybody? So what is x? X cannot be plus you. Negative 3 plus you. And x cannot be positive 3. Good. So you have draw the picture. The real number line. X cannot be negative 3. So you put an open circle. If you know you remove that point. And x cannot be 3. So you remove that point. Therefore, if you want to use interval notation, look at, it's from minus infinity. So here is minus infinity up to negative 3. We don't want to include the negative 3, so we use parentheses or brackets. Parentheses. And then union, negative 3 to 3. We don't want to include the 3, so still parentheses. And union, 3 to infinity. So this is the interval notation. Oh. I can decide it. Maybe 1 point off. Yeah, at most 1 point off. Okay, yeah. So this means union. It could be here or here or here.
And what would do with the top one though? The x plus 2.
Oh, sorry. Attendance. Okay. Thank you. And the top one? X plus 2, where? Oh, okay. Do we care about the numerator at all? No. So don't do anything to it. Your smaller number must be on the left. Yes, because the real number line. Your right hand side is more positive, the left hand side is more negative. That's why, remember I told you, if you see 3, 1, is this an interval? No, it must be a point on the xy plane. It cannot be an interval because your left number must be smaller than the right number. Yes, very good. All right, let's keep going. Okay, part B. Oh, you see square roots, everybody? When you see square roots, the things inside the square root, which is 2x minus 6, need to be greater or equal to 0. Right, everybody? For inequality, we can add or subtract a number. It won't change the inequality. When we multiply or divide it by a positive number, it won't change the inequality. But if we multiply or divide it by a negative number, what happens? Yeah, it switched the inequality, right? Okay, so how do we solve for x? X6 on both sides. Then we have 2x greater equal to 6. And then divided by 2. Yes, we get x greater equal to 3. Right, everybody? And yeah, divide by 2 because 2 is positive, so it won't change the inequality. So this is good. And you want to draw it on the real number line. So 3 is here. Do we include a 3? Yes, greater than or equal. Right? So we include a 3. Open circle or solid circle? Solid. Okay, left or right? Right. Yay. So how do you use the interval notation? 3? Yes. Parentheses. Perfect. Yes. So this is how to find the domain of this function. Okay, everybody? You check 2 things. Do you see square root? And do you see fraction? Okay. If you see square root, set the things inside the square root to be greater or equal to 0. When you see fraction, set the denominator not equal to 0. Yeah. All right. Now, part C. It kind of has a mixture of part A and B. We see a square root. We also see this thing is in the denominator. Right, everybody? So because of square roots, we need the things inside the square root is greater or equal to 0. Because of the square root, right? Also, because this is in the denominator. So in the denominator, then it cannot be 0. Right? Yeah, because it's in the square root, it's greater or equal to 0. But it's also in the denominator, it cannot be 0. Therefore, this means x squared minus 9 must be greater than 0. So far, so good, everybody? Okay, now I want to show you a wrong solution. A wrong solution. Okay, let me use a black color. So, okay, I move the 9 to the other side. So I add 9 on both sides. And then I take the square root. I get x greater than plus or minus square root of 9, which is plus or minus 3. Okay, I have x greater than 3 and x greater than negative 3. This is a wrong solution. That's why I said if you have equation, you can move the 9 to the other side, and you can take square root. No problem for equation. But when you work with inequality, you cannot do that. Okay? So now I'm going to teach you the correct solution. And then you tell me what's the difference. Okay. So this is wrong. Okay. So let's see. What we should do is factor the left hand side. Move all the terms to the left-hand side and factor. So when you work with inequality, you must do that. So we already move all the terms to the left. So when we factor, we get, again, x plus 3 and x minus 3. Right, everybody? So we factor, we get that. And then the next step is find critical number. So critical number, to find critical number, you set each factor equal to 0 and solve for x. Okay? So you set each factor equal to 0. You get x plus 3 is 0 or x minus 3 is 0. What's x?
So it would be -3 and then 6. Or, I'm sorry.
Yes, good. This is the two critical numbers. So after you get the critical numbers, you draw the real number line and you mark those critical numbers. So -3 here and 3 is here. So far, so good, everybody? Okay, and then you look at this inequality. Greater than, it means we don't include the endpoint. So you put open circle there. Okay, so because it's positive, do not include the endpoint. That's why open circle. If you have greater than or equal to, then you put solid circle on the endpoint. Is that okay, everybody? Okay, next. Do you see the real number line that separate into 1, 2, 3 subintervals, right? These subintervals, what you do is each subinterval, you pick a test point, and then you plug in the left-hand side to see if it's positive or negative. Can you give me a number in this interval? -5 or -4. Yeah, both works. And we just need one. Okay, how about, let's do, okay, -5. So we plug in -5, and our left-hand side, it becomes -5 plus 3 is -2. And multiply by -5 minus 3 is -8. -2 times -8 is 16, right? Which is positive. So it's positive, then you can put it above the line. Okay? It's positive. Okay. All right. Can you give me a number here? 2. Do you see an easier number?
0.
Yeah.
Yes, 0. That is easier. So we plug in 0. And then the left-hand side is what? We plug in x is 0. So 3 times? Yeah, 3 times -3. Oh, do you see it's negative? Yes, it's negative, so it's below the x-axis. You can think of this line as like x-axis. Okay, everybody? All right, this interval. Give me a number. 5. Okay, if we plug in the 5, what is the left-hand side? 5 plus 3? 8. 5 minus 3? 2. Oh, do you see this is positive? Yes? So it's above the x-axis. Okay. Therefore, oops, sorry. Where's my line? Okay, here. Therefore, you get here is positive, here is negative, here is positive. And we are looking for positive, right? That's why it's this region and this region, this two regions. So what can we say? Minus infinity to what? -3. Bracket or parentheses? Parentheses. Union. Yeah, very good. 3 to infinity. Look at this. Look at this answer. Yeah, x greater than 3. That's true. But is x greater than -3? No. It should be x greater than 3 or so not that or x less than -3. So that's why it's wrong. We cannot just move the 9 to the other side and then take square root. This won't work for inequalities. Inequalities, you have to work more. Look at the left. You have to move all the terms to the left hand side and then factor. And then set each factor equal to 0 to find the critical number. Critical number is critical because it determines your exchange sign. Okay? On the left, on the right, you might have different sign of the inequality. That's why it separates the real number line into some subintervals. And on each subinterval, you can pick a test point to plug in the left-hand side to see if it's positive or negative. And then you look at the inequality. You're looking for greater than 0, which is positive. So that's why you pick these two pieces. So far, so good? Okay, so we will talk about how to solve inequality more. Okay, so here you only have 2 factors. Later on, we will talk about if you have a product of many factors, then what do we do? So we'll talk about this more. Okay. Any questions so far? All good? Okay. So this method is called the testing points method. If the problem gets more and more complicated, I will teach you another method. So we'll go back to how to solve polynomial inequalities later. Okay. All right, next. How do we graph piecewise defined function? Okay, example. Consider this piecewise defined function f of x equals to x squared. What's x squared look like? X squared, X squared, yeah, bravo, right? How about linear function, a line, right? Okay, it depends on the slope. Remember the slope is the coefficient of x, right? If the slope is positive, our line looks like this. If the slope is negative, and our line looks like that. Right, everybody? Okay. First, find the domain of f. Okay, look at the piecewise function. These tell us the domain. If x is less than -1, we use this formula, right? And if x is greater than 0, we use this formula. Okay, everybody? So the domain will be, so if you draw the picture, see? -1 is here. X less than -1, so which is this part. We'll use the first formula. And 0 is here. If x is greater or equal to 0, we use the second formula. Is that okay, everybody? This is the real number line. Therefore, your domain. So part A, the domain is, see? -infinity to -1. Parentheses or brackets? Parentheses. Union, what? Very good. Yes, this is the domain. Right, everybody? Okay, now we graph the function. Okay, let's graph the function. Okay, draw a long line. Okay, this is x-axis. This is the y-axis. And that's the 0. Okay, everybody? So when x is less than equal to -1, we're using the first formula. So -1 is here. We use the first formula. So let's plug in. if x is -1, okay, we plug in the first formula. Do you see we get -1 squared? What's that? 1. Okay, -1, 1 is here, right? So -1, we look at this formula, right? So -1 squared is 1. Okay, put a little dot there. Don't put a solid circle because do you see x is less than? Do we include the endpoint? No. So actually this point is missing. So you can put a open circle here. This point is actually missing. Okay, and let's do more. So what number do you want to plug in? Can we plug in 1? Or can we plug in, we go to the left, right? Yeah. So -2. What's -2 squared? 4. So -2, we get 1, 2, 3, 4. 4 here. Okay, this point we can put a bigger dot. And then we want to connect them. So you know your parabola look like this. Okay? And let me draw it here. So you know this is your parabola. It look like this. So we restrict your parabola to only to the region x less than equal to -1. So it's a portion of the parabola. Is that okay, everybody? Mm-hmm. You don't draw the entire parabola. You know the total picture of what it looks like. Okay, we only restrict to this piece. X is less than equal to -1. So this is the first piece. Okay, everybody? Yes. Mm-hmm. Now we draw the second piece. Okay. The second piece. We look at 0, right, everybody? We plug in 0. What happened? 2 times 0 minus, yeah, so -3. 0, -3 here. Do we put an open circle or solid circle? Solid. Yeah, x can be 0.
Oh, okay.
Yeah, so we can include the endpoints. Very good, very good. And so here, exclude the endpoints. Here, include the endpoints. That's why this piece exclude the endpoint. But this piece will be including endpoints. Yeah, this is a line. And so 2 points can fix the line, right? We just need one more number to plug in. What number do you want to pick? 1. Right, everybody? We can plug in 1. 2 times 1 minus 3 is -1. So at 1, we get -1, which is here. Okay, now you have your student ID. Use it as a ruler. Okay. So this is the line. Use your phone. That works. Use your line. Yeah. Yeah, I have one of the. Okay, so this is the piecewise function. Okay, everybody? Mm-hmm. All right, let's continue. Okay. Eh? What happened? Oh, okay. Now it's your turn. Please draw this piecewise function. So look at each piece. Look at what are x values. Find some points to plug in and connect the points together. Do you need a worksheet? Do you have other worksheets too? No. Oh, okay. So this is a prerequisite review. You can work on it over the weekend. So it's something you learned before. So give it to me on Monday. And this is a scanner. This is you can write down the information number put in here. And so I can explain it to you. This is the worksheet for this week. Do you know how to go to Blackboard Collaborate and see all the recordings? Okay. So, yeah. We are now here. So that's this one.
Is this for start meetings or is it now?
Oh, your own use. So, every week, so you can print out the worksheet. The first week, I print out the worksheet for you. So from the second week, you can print out on the website. So, do you know how to print stuff? You use the library? Okay. So, yeah, you can see all the worksheets.
So here, y equals.
Yeah.
Oh, okay.
Low and negative.
Bring it to class, because it can save you time. You don't need to save you time. So save you time, just write down the income and stuff. And
Yeah,
then
that's what I did too.
at the end of the semester, you show me a note, you get one
Low
point.
negative.
Okay. Welcome. Okay. So how about, okay,
Just start.
continue, good.
Go down straight. Let's say negative. And then the next one is just one. Which is just a straight
Yes. So this is the first piece, and oh, you also have a second piece and the third piece. So you have three pieces.
Hey, I don't know your phone line.
This is the first piece.
Run that one.
And then here is from -3 exclude up to the 0 include. So this is second.
Yeah, negative, yeah. Oh, zero.
And then this is the third.
Yeah. And that's just y equals negative.
Yes, so actually you don't need.
Yeah, to 0, so it needs a 0. This one.
Then zero.
There.
Yeah.
Okay, yeah.
Because it does, because this one does it, this one does it. So it's still splits out.
Alright, so just connect.
I don't know why this is a close out. I get why that one. But why is this one? Because this one is close.
Ah,
So
that
it's
should
just-
have it.
Yeah.
That one.
Yeah, it's just they're at the same point.
Why do you do -2 instead of the -3?
Oh, very straight line. Can you use your phone?
Like,
Oh, that works. Yeah, yeah.
Oh, that's negative.
Right.
oh my God, negative.
Yeah,
Where
it's at
we-
negative.
Oh,
Yeah,
okay.
I should
So
do it.
we,
Yeah, that makes more sense.
the first piece, x is less than equal to negative. You find out, oh, okay, where's negative now? And you, the formula, you want the -3 to get -3. Well, x is -3, y is also -3.
It will be at the point,
Yeah.
if it is
At the point now.
-3.
Then you look at this. This is less equal. And there's one more point. And this piece is here. So you need
No,
one more
like on a
point.
technicality, right? Like,
Negative 5. Negative 5 here. Okay, next. It's also negative 5.
That's when, so you do, what's the square root for? 2. So that's,
Right. And you see.
Oh,
X
so you
is
just find the
one.
first number and then like.
2 points can fit that one.
I know why you put that one down.
How do you know you went forward?
so that's the next, square root of
Ah.
next 100.
Okay. So -3. The first one where you.
So this one, so when it's y equals x, it's just
And
a
you come
straight
here.
line.
So -3 plus x is -3.
Starts
Plus
here,
-3.
so it'll be like negative 1, this one, negative 2, negative 3, negative 3. It's a straight line.
So that's the point this right.
Yeah.
and including here. And then because this is x less equal to negative, you need one more point. So my suggestion is don't put so many bars. Put the bar as needed. So see, you need negative 3, okay? And then you multiply negative 4. So don't put so many. Oh yes. Yeah. Okay. How about let's do this together, and then the next exercise, you do it. Yes. Oh, square roots. Okay. All right, let's do it together. So, here we have, this is first, second, and third, right? We draw the real number line, and that's x, and the vertical axis, that's y. Okay, and 0 is the origin. Look at the first piece. X less than or equal to negative 3. Where is negative 3? Oh, look at it. X, yeah. Sorry. Right. So, x is negative 3. So this is negative 3, right? And then, because the formula is x, so x is negative 3. Yeah, right. We go down to negative 3. And we put a little dot there. Then, we look at this. Look at this. X less than or equal to negative 3. We include the endpoints, right? So here, we put a open circle or solid circle? Solid. We include the endpoints. So we put a solid circle here. Okay? But this piece is actually on the left-hand side of negative 3. We need more points. So give me another number you want to plug in. Negative 4. Right? So we can plug in negative 4. And look at the formula. X. If you see a linear function, you know it's a line. And 2 points can fix a line, right? X is 4. So that means the y is also negative 4, right? So y is also negative 4. So negative 4 here. And now you can connect them. You know it's a line. So 2 points can fix a line. This is the first piece. Is that okay, everybody? Let's draw the second piece. Okay, draw the second piece. And look at the left. So x is from negative 3 to 0, right? And the y coordinate is always negative 3. Do you see? It's a constant function, right? It's always negative 3. So it's a constant function. And here, do we put an open circle or solid circle? Solid. Because it's less than or equal to 0. It includes the endpoints, right? So we put a solid circle here. This is the second piece. Now, let's look at the third piece. Okay. All right. So even though x is not equal to 0, but we can still plug in the 0 to find where the point is. So we just put an open circle at that point. Okay? So when you plug in x is 0, what is square root of 0? 0. Square root of 0 is 0. See, the point is the origin. But because you don't include the endpoints, you put an open circle at the origin. Is that okay, everybody? So open circle here. And then, what's the next number you want to plug in? 1. Square root of 1 is 1. Okay. And do you remember what square root look like? Yes? Everybody? Okay, what is the next integer point you can plug in? 4. Yes, square root of 4 is 2. Very good. So 1, 2, 3, 4. 2. Okay, now you connect them together. Okay, so this is the third piece. Okay, so this is how we draw the piecewise function. We look at each piece, and then we pick some points to plug into the formula, and then we connect all the points together. And then when you have the endpoints, be careful. Do you see an equal sign here? If yes, you include the endpoints. If not, then you exclude the endpoint and put open circle. Is that clear to everybody? Okay, now you do the next problem. Okay, yes, do the next problem. Yes, because y equals x and x is negative.
So,
So you just introduce that when you define that.
yeah. Yeah. So you go to, yeah, that's one. Negative one.
Oh, okay, so it's negative one.
Yep. Yeah. Yep. Yeah. Oh, it's just parabola. So it's just, go.
So you just put them like this.
You start, yeah, you start with you start at negative 1x, so that's where the starts. And it's just a straight line. That's yeah, that is, yeah, and then, yeah, that was.
Oh, this is right.
This one, that's this one, the negative one is this one. So it's just, that's, these are like y. Just kind of straight lines. Straight lines.
Oh, so this is one of those for the first one?
Yes.
That one?
Oh, so x is negative 1. It's negative 1. Y is negative 5. And it's a
So this is one,
so it's a horizontal line.
Oh, so this the third one is this one?
Yeah, horizontal line.
the second.
So here, from here. This is the first piece. Is a horizontal line. Do you include the endpoint or not? You don't.
Oh my god.
Yeah. It's better. This is where you start. Yeah.
No, no, not yet. So,
It's just you put in, I just put in 0, just to get the points.
And then the second piece
Okay, explain. So that's just a front one, right? So
Yeah.
you take two, put it in the water for ice.
Open circle or solid circle?
For this
Because
one.
it's less.
Oh, for that one. Oh, I already did that one. I was like, wait.
How did you get
Like, or, like, how do you know that?
Because this two is where the last one is.
Oh,
So like,
so for all this.
So open circle.
okay. So it'll start at knowing that, and then it'll
So
just go
label
straight
it. Two square is.
down. So the slope is.
Yeah, so.
No, I'm sorry.
So label it.
I go there, so this is where.
He just has no fear like
I
that.
ran pencil.
He just knows he's
This
like,
point started at two.
he's smart.
Straight line.
Okay, so we haven't finished the
Because
first
it's,
one.
so it starts up at
X
two.
less than negative one, so if you straight all the x's on the left hand side, it's gonna be constant.
The y, so the
So
line
you
is
put
this one.
a horizontal line there. It's always remain the same side. And then
Here.
second piece, you plug in this formula, -1 squared. Yeah, see, so -1 and then the y is 1.
Because the slope is -1.
Yeah, use this number.
Oh, so you start.
Because the second piece is from -1.
I'm talking about the last one. You guys were all in different parts.
Oh, so here,
It's on the second one, bro. We're on the second one, bro.
We're not on the second one, we're just on the third one.
Because this piece, -3, and on the left hand side, we plug in -4. -4, x is -4.
Yeah. So it's -1.
Oh, you can take out a number. So this piece means it's on the left hand side of negative. You can choose -4 or -5.
Next one's 0.
Because this is a line, you just need 2 points. Yeah. Yeah.
Oh.
Yeah, because this is this piece. And the middle piece, you use this formula. Like here, the middle piece, use this formula. So you usually we put the m point. So m point is -1, -1 squared
I got
is
you.
1, right? So it's this point. Then do you include the end point? Yeah, so solid
Well,
circle.
no, it's like. Yeah, kind of a.
Yes.
Well, yeah, it'd be a check.
Yeah.
Okay.
Maybe 1.6
You got the last one.
because you use the
So-
last one. 2.
Okay, so.
Here. Not -2 here. So
You know
not
what?
-2. So how do you know it's here?
Yeah.
And I think you want to 0 as well because you want to know because it's not a line. It's actually a graph.
You just explained it.
So if you put more
So you started
points,
from 0 to
because in this case, 0 is in there. So if you know the shape of it, then you can draw it. Otherwise, you can
Start.
So how do you set it
So
down?
this is
Yes,
the
the
line.
end one is yes.
So you're just like subtracting one.
Bro, how is it all? I'm dropping all my.
So you are.
Yeah.
Good.
What's
Yeah,
it
what's
finding?
the
Is that a client?
Okay, so look at the end point. The end point is -1. Then you use this formula. -1 squared is.
Where are you getting these numbers from?
From the equation, just look.
Yeah, so that's like -1 here. And do you include the end point? Yeah, so put a solid circle. Okay, and then, okay, keep going. 0. If you plug in 0, 0 squared is 0 here. And you plug in 1 squared. Yeah. And you see, you go up to 2 squared. Yes.
You don't
And
gain
with a piece. And open circle or
This is the first one, that's the second one. That's the
Yeah.
third one. So instantly, you're starting at -5, right? Okay, so that's this.
Oh,
point
open
right
circle
here.
or solid
Yeah, I got
circle?
that part.
Okay, well then your first one's done. This is your first one right here. Okay.
Yeah.
This one right here, this
Yeah.
is your second one.
Yeah.
And
This
this,
equation.
you don't go beyond
This
that.
equation is the one where it goes.
Minus 1 is
Yeah, I
the
get that part, I just
endpoint
don't know how
of
to
this
graph.
Oh, pretty quick.
So you got
Yeah, exactly.
take this,
Oh, no. Here, longer.
that's for that. And then,
Oh, then you use the next piece.
yeah.
Go into here.
There's
Yeah, anything else you do.
that gets
Right.
washed.
Oh, yeah,
So-
And this is the open circle. This point is open circle.
But only one of these. So you
Yeah,
go to that whole
2
thing.
square. Yeah, this is a still the line. So I think the question is like, include in the curve. Alright, let's check our answers together. Okay. Alright. So, the first piece, the endpoint is what? -1, right? So -1, and your y coordinate is -5, right? And you find the points. Do you put open circle or solid circle? Open. And on the left hand side of it, do you see is a constant function, -5? Yes? If you just get a number, that's constant function. Constant function is a horizontal line, right? Everybody, the y remains the same, always -5 on that piece. So this is the first piece. And then let's look at the second piece. Second piece, do you see the endpoint, -1, right? This is -1. You plug in the formula. What's -1 squared? See, your formula, 1. And then you look at, okay, is this open circle or solid circle? Solid, right, everybody? So good, thank you. And so we put a solid circle here, okay? And x squared, what's x squared look like? I love you, right? You shape. So we know it's gonna look like that, but let's be more accurate. Let's plug in 0. 0 squared is 0. Keep going. 1 square. 1. Keep going. 2 square. 4. Okay, see, that's the endpoint. So is it an open circle or solid circle? Is it an open circle or solid circle? Open. So 2, 4 is an open circle, and we connect them. Is that okay, everybody? Look at the endpoints, open circle or solid circle. Connect the points. Okay, last one. Last one, x is greater or equal to 2. See, the endpoint is 2. We plug into the formula. What's 2 minus 2? 0. Okay, 2, 0. Open circle or solid circle? Solid. Yes. And 2 minus x, what's the power of x? What's the degree of this? 1. So it's a linear function, right? So it is a line. How many points can fix a line? 2 points. We need 1 more point. Give me another point. Greater or equal to 2? 3. So 2 minus 3 is -1, right? So 3, we get -1 here. Okay, 2 point can fix a line. So I can draw the line. All right. So this is the piecewise function. Okay, everybody? All right, good. Let's keep going. Okay, so yeah, we continue on 1.3, and then next week we're gonna talk about 1.4. So remember to print out your notes for next week. Everybody, do you all know how to print out the notes? If you don't, please raise your hand. Don't be shy. I can teach you.
I have a question.
Sure.
So I
Oh, then you can use it.
convert it into a PDF and it converts back into a PDF and then just like email it to you.
Oh, you mean your notes?
Yeah.
Oh, your notes you can save to your computer. You show me your notes and in the last week of the semester.
Oh, no, I'm not talking about those. I'm talking about
I don't know the same thing she did.
Oh, yeah, then email me. Yeah. You mean the prerequisite one? Hey, do you have a PDF version of it?
Is it on there, PDF?
Huh?
Is it on there right now?
I don't think it's there. Did you get a paper copy of it?
Yeah, I'm just doing it.
Oh, okay, yeah. Okay, this is extra. It's not your homework. It's not counter module. Yeah. Okay, yes. So, all right, let's continue. 1.3, rate of change and behavior of graphs. Okay. First, increasing, decreasing, and constant function. Have you learned this before? No. Okay. So let f of x be defined on an interval from a to b. Suppose x1 and x2 are in that interval. So f is increasing on that interval. So increasing on that interval. If, look at this picture. So x1 is smaller than x2. And your y value, f of, so let's say here. So this is f of x1 and this is f of x2. So your f of x2 is greater than f of x1. Do you see the y value is increasing? So this is the increasing function. Okay, so your x, you look at it from the smaller to the bigger number, and then you look at your y increases, then this is the increasing function. Is that okay? Alright, next, f of x is decreasing. On that interval, if x1, x2, if f of x2 is less than f of x1. Make sense, everybody? That's decreasing. Because your y values decreases as you increase the x. Okay? So you always look at your x from the smaller to the bigger number. And you look at your y values is decreasing. Right? So the function is decreasing. So far, so good, everybody? And then f of x is constant. So constant if it remains the same. So x1, x2, it remains the same. That's a constant function. So far, so good, everybody? Okay, next, relative maximum and minimum. Suppose x equal to c is in the domain of f. And f of c is a relative maximum. So it's a relative maximum if f of c is greater or equal to f of x, where x is near c. So the picture is this. Okay, so this is the relative max. Yeah, it makes sense because this point is greater than all the other values near it. So it's really the highest point. So this is a relative maximum. Okay? And f of c is a relative minimum if f of c is less than or equal to f of x, where x is near c. Look at the picture. This is the lowest point. So it's a relative minimum. Okay? It also has other names. Sometimes some textbooks call it local maximum and local minimum. What's local mean? Okay, look, imagine your graph. Okay, your graph. Okay, maybe your graph looks like this. Something like this. Okay, this is your graph. Then this is a local max, right? This is the local mean. This is the local or relative max. This is the relative mean. Is the greatest points for the value near it. But it's not the absolute maximum. Absolute maximum is the largest y value of the entire graph. In this case, because if your graph, let's say it goes forever, then we don't have an absolute maximum. Okay? But this is the relative maximum. It's for the x near it. This point is the greatest number for the x near it. Okay? That's why it's also called local maximum. It's not a global maximum or absolute maximum. It's a local maximum. Is that okay, everybody? Similarly, what's this? Relative max. This? Relative minimum. Okay. Let's say if our graph looks like this. This point is the relative minimum. It's also the absolute minimum. Because here it goes there forever, this up forever. This is really the lowest point of the entire graph. Okay, so this is an absolute minimum as well. Okay, very good. Okay, so use the graph of f of x that is given below to answer the following questions. Okay, so determine the interval on which f is increasing and on which f is decreasing. Okay, so I feel like looking at the graph is riding a roller coaster. Have you played? Yeah, roller coaster? Yeah. Yes. So you're riding here. And this is decreasing, right? And stop here. Then you are increasing, right? And then you are decreasing, decreasing. Right. So look at the picture. Let's figure out the interval. So let's see. F is, let me put increasing here. And F is decreasing. Let's put here. Okay. How about you guys answer my questions one by one? Okay. This increasing or decreasing? Decreasing. And what do you say the interval is from? Arrow. It means negative infinity up to -1. Okay. So decreasing, right? Minus infinity to -1. And please always use parentheses. Don't use brackets, okay? When you say it's increasing or decreasing. Because the endpoint doesn't really tell you anything. So just use parentheses. Okay, next. -3 up to what? So, sorry, -1 up to what? 3. Increasing or decreasing? Increasing. So -1 to 3, right? Next. 3 to what? 6. Increasing or decreasing? Decreasing. Good. 3 to 6. Okay, next. 6 to what? 7. Increasing or decreasing? Increasing. So 6 to 7. Okay, next what? 7 to 9. Increasing or decreasing? Decreasing. And do you need to put a bracket at 9? No, don't put bracket. Just put parentheses. Okay, everybody? And finally, what? 9 to infinity. Increasing. Yes. 9 to infinity. Increasing. Right, everybody? Yeah. Yes. Okay. Good. Okay. Yes. Last year, I sent my kid to California Disney Park. And because my kids are small, they're 8 years old and 4 years old, so we only play the small. I like to play this one. But I have to stay with them, so I cannot play. My husband is afraid of heights. So yeah, when we go to Six Flags together, I just join and play the roller coaster, and he just stayed down there and watched me play. And yeah, he watched our backpacks, but I feel a little bit lonely.
That's what mom does too. This one where she doesn't like it goes like it's like you're up and it goes drops straight down.
Oh, I like that.
What's this one do you go to? Which one?
Is it in Illinois?
Illinois? Oh, Greater
Yeah.
America? That's one I go to.
Oh, okay. Good. Oh, it has that one. Did you play?
No, it's like a drop tower. It's like you're
Oh, it's dropped down?
yeah, you just like
Oh.
you're facing like to the horizon and you're just like yeah.
Oh, that's cool. That's cool. Oh, okay. Maybe we can continue on Monday. All right. Have a nice weekend.
Monday sounds good.
Yeah.
Same time.
Yeah.
I hope you have your mouth shirt on.
Oh. Yeah, I see. It arrives. Okay. So